So we're still talking about end behavior, but instead of the graphs approaching positive infinity or negative infinity, graphs can approach an actual number instead. It's not as common as positive infinity and negative infinity, but it's good to at least recognize. So let's look at these last examples on this last page of 2b. So as x moves towards positive infinity and negative infinity, so as x moves towards the right or towards the left, it's possible for f of x, which is the outputs, to be approaching a certain value. Describe the end behavior of the graph to the left and the right. So we've got our notation here. This is written in a little different order. This says as x approaches infinity. So you do have to pay attention to the way it's written. This is saying the right end because it's x approaching infinity. So as we go towards the right, we want to know what's happening to the outputs. So let's look at the right end of the graph right here. Now, notice this is not going down. The right end is not going down. It's actually kind of flattening out and approaching a specific number instead of going down infinitely. So if we look at our graph here, we've seen graphs like this before. It looks like the graph is getting closer and closer to this line, but never actually touching this line. This is an asymptote. Okay, so this graph is getting closer and closer to this line, and this part of the graph is getting closer and closer to that same line. So what we want to do here is, instead of the outputs or the y values approaching positive infinity or negative infinity going up or down, they're approaching this y value. And this y value right here is at -1. So as x approaches infinity, f of x approaches -1. That means the outputs are getting closer and closer to -1. Same thing on the other side. As x approaches negative infinity, so that's going towards the left on the x-axis, this is describing the left-hand side, f of x approaches, same thing, the graph is getting closer and closer to this line, which means the y values are getting closer and closer to -1. Okay, so the only time this will happen where the graph is approaching a number rather than positive infinity or negative infinity is when there is some type of asymptote. So remember, an asymptote is a line where the graph gets closer and closer to, but doesn't touch. All right, so let's just look at a few examples like this. So here's our examples 21 and 22. We're trying to find the end behavior. This one, the format that we usually write it in is given to us. This one is the order where we have been doing. As x approaches negative infinity, so that's describing the left end. And as x approaches positive infinity is describing the right end. So what might be helpful here is to look at our graph and look for any asymptotes where the graph is getting closer and closer to some line, but never actually touching. So if we look at this graph right here, the graph is leveling off and going straight to the side. So it looks like there's an asymptote right here. The graph is getting closer and closer to this line on both sides, but never actually touching. Now, there also is a vertical asymptote here, where the graph gets closer and closer to that line, but isn't touching. However, that isn't affecting the end behavior, because when we're looking at end behavior, we are only looking at what's happening at the ends of the graph. Okay, so I'm looking at the left end and the right end. All right, so let's fill this in. As x approaches negative infinity, that's talking about the left end. As we go towards the left on the x-axis, the outputs, remember f of x is the y values or outputs. here, the y values are approaching this line. This line has a y value of -3. So f of x approaches -3 as we go to the left. Now, as we go towards the right, the same thing is happening. The y values, the outputs aren't going up or down. They're approaching this straight line. So the y values are also approaching -3 on the right side. Both the left side and the right side are approaching -3. All right, so now let's look at 22. So another thing we might notice on this one, it also has an asymptote. Again, an asymptote is the line where the graph gets closer and closer to, but doesn't touch. So if we look at the graph, it's leveling out here and going straight to the two sides. It's never crossing or touching the x-axis here. Okay, so drawing that asymptote in will help us describe the end behavior. There, again, is a vertical asymptote, but that doesn't matter for the end behavior, because remember, end behavior, we're just looking at the two ends of the graph. So let's fill this in. As x approaches -infinity is talking about the left end. So as we go towards the left, we can see the end of the graph is getting closer and closer to this line, but never actually touching. So it's not going infinitely up or infinitely down. The outputs, remember f of x is the y values. The outputs are getting closer and closer to this line, which has a y value of 0. So the outputs are getting closer and closer to 0. So we would say as x approaches -infinity, f of x approaches 0. And on the other side, as x approaches infinity, that's talking about the right end. As we go towards the right, we can see the graph is getting closer and closer to this line. That means the outputs, remember f of x is the outputs are getting closer and closer to 0. When there's an asymptote, usually both ends approach the same asymptote. So as x approaches -infinity, f of x approaches 0. And as x approaches infinity, f of x approaches 0. This just means the left end gets closer to 0 and the right end gets closer to 0. Okay, let's look at two more, I think is what we have on our paper. All right, so we've got 23 and 24. We're trying to do the same thing. So if we look at 23, hopefully this type of graph looks somewhat familiar. You have seen exponential functions before in Algebra 2. We can see we have this asymptote where the graph is getting close to this line, but not touching. Okay, so let's describe the end behavior. So we're trying to describe the two ends of the graph. Now, in this case, our two ends are going in different directions. All right, so again, we have our notation here to fill in. As x approaches -infinity, this is talking about the left end of the graph. As we go towards the left on the x-axis, what's happening to the outputs, the y values? So on this end, as I go towards the left, my graph is going infinitely up. So since the graph is going up, we would say f of x approaches infinity. So the left end is going up infinitely. Now let's describe the other end. As x approaches infinity, that's to the right. As I go towards the right on the graph, as I'm tracing the graph right, the right end is getting closer and closer to this line. So the right end is not going up or down. So it's not positive or negative infinity. It's getting closer and closer to this line. That means the outputs, this line has a y value of 1, 2, 3, 4, 5, of -5. That means the outputs on this end are getting closer and closer to -5. Okay, so instead of going up or down, the y values towards the right, as I'm going towards the right, are getting closer and closer to -5. All right, we have one last example. This one doesn't give us the notation to fill in, so we're gonna have to fill in both ends. So let's look at our graph. Remember, for end behavior, we're only looking at the left end and the right end of the graph. So all this stuff in the middle doesn't matter when we're talking about end behavior. We're only looking at the ends of the graph. Another thing you might notice on this graph, it does seem to have an asymptote right here where the graph gets close to this line but doesn't actually touch. Okay, so that's going to be important. All right, so let's look at the two ends of our graph. We need to describe the left end. So as I'm going towards the left on my x-axis, here's my graph. The left end of the graph is not going infinitely up or infinitely down. It's getting closer and closer to this line. And this line, this output or y value, is at -2. So the left end gets closer and closer to -2. The way I would say that, I can say left end approaches -2. If I could spell approaches. Okay, at left end approaches -2. And then let's describe the right end, and then we'll go ahead and use the notation on both. So now let's describe the right end. As we're going towards the right on the x-axis, so I want to describe the right end. This time, the right end of the graph is not going infinitely up or infinitely down. Same as before, it's approaching this line, which means the y values, the outputs, are getting closer and closer to -2. They're getting closer to this line. So we would say the right end approaches -2 as well. Okay, so both ends approach -2. So that's how we would say it in words. We'd actually have to write out approaches. Let's put that in our symbols. So if we're describing the left end, left and right is talking about x. So we would say as x approaches -infinity, that's the left end. F of x, that's the outputs, approaches -2. So this is saying the left end gets closer and closer to -2. As x approaches -infinity, f of x approaches -2. And then I have to describe the right end. So as x approaches infinity, f of x approaches -2 as well. So this is saying the right end, on the right end, the outputs get closer and closer to -2. Or as x approaches infinity, f of x approaches -2. All right, so that's how we would write it in the correct notation. But as we've seen, we're not really able to type this kind of notation very easily. So we would just describe it in words instead if you were typing it to me. So the left end approaches -2 and the right end approaches -2. Okay. So now we have finished the 2B note.